All right, so let's get going. So, example three is on more properties of inscribed angles that specifically relate to when we have a semicircle as our intercepted arc, as well as some other properties of inscribed angles, particularly relating to when inscribed angles overlap and have the same intercepted arc. But I don't want to say too much because I know that since the moment you woke up this morning, you've been wanting to learn how to do this. So I'm going to stop talking so I don't give it away. All right, so the first problem we're going to deal with involves a semicircle. So this has to solve for the value of x, okay, which x is inside of angle RQT, okay, which I'll highlight that angle since that angle is what we're focusing on. So this is drawing an angle to angle, you could say angle Q. Sometimes it's more helpful to use 3 letters so you're more specific, but it doesn't matter either way on this one. So this whole angle is 4x plus 6. So x is involved with that angle. So I'm going to highlight it so we know that it's involved with that angle right here. Okay, and since we've been talking about inscribed angles, okay, inscribed angles have a relationship with their intercepted arc, okay, as which the intercepted arc starts and ends where my inscribed angle starts and ends, which again, I know this is an inscribed angle because the vertex is on the circle. Okay, so I'm going to highlight the arc that it opens up to, which actually, I can't really name this arc because it should have 3 letters to name it, which I don't, okay? Which I'll explain why it should have 3 letters, even though it doesn't, but that's okay. All right, so this angle starts here and ends here. So the intercepted arc will also start here and end here. And don't forget, you guys, arcs must go around the circle. Don't cross through the circle or the demon cats are coming. Watch yourself. All right, so that relates to this arc right here. Okay, and this arc starts and ends along this segment right here, segment RT. What kind of segment is RT since it starts and ends on the circle and it hits the center? Okay, well, I agree. Technically, it is a chord, but it's a more specific chord. What chord must hit the center points on the way down? It is, in fact, a diameter, which a diameter goes through the halfway point of the circle. Guys, so this is half of our circle. The entire circle, if you didn't know, is 360 degrees. So what would be the measure of half of the circle, or the half of the arc of the circle? It would be, in fact, 180 degrees, which means it's a semicircle. So I know that this right here is 180 degrees. Whoa. My mind is blown. Guys, technically semicircles you're supposed to name with 3 letters, but I don't have an additional point in there. I could like throw in a point if I wanted to. So let's say that this is point, I don't know, Z. So I could call this arc RZT. So I'm going to say the measure of arc RZT equals 180 degrees because it's a semicircle. So that's good to keep in mind. Guys, so if we think back to that lovely property you guys learned about in the Prezi, not that one. That's the one we're about to talk about. Okay, this is the one we're talking about. Not this one, so ignore that one. I'm going to zoom up so you can't look at that one. Guys, so if an inscribed angle's intercepted arc is a semicircle, then it measures 90 degrees because 90 degrees is half of 180, which if you guys remember, inscribed angles are half the measure of their intercepted arc. So the intercepted arc is a semicircle, 180 degrees, and half of 180 is in fact 90 degrees. So we're using that theorem to finish solving this problem, which technically you probably could have understood that without knowing that theorem. But it's always good to fall back on lovely theorems that mathematicians come up with. Okay, so this angle is half the measure of that one, which means half of 180 is 90 degrees. So this is a right angle, which means it's 90 degrees. Whoa. My mind is already blown, you guys. I don't know if I'll be able to finish this problem, but I must, because ultimately my life will not be resolved unless I finish this problem. All right, so let's get going. So I know the measure of angle RQT should now equal 90 degrees. So the measure of angle R to the Q to the T equals 90 degrees. Okay, so let's get going. And we got that by doing 180 over 2 because it was half of the semicircle. All right, guys, let's start filling in our values to solve. So the measure of angle r to the q to the t is 4x plus 6, which actually you don't really need the parentheses. I'm going to start with them, but I'm going to instantly drop them because you don't really need them. All right, so again, the parentheses you don't really need, so I'm going to drop them. 4x plus 6 equals 90 degrees. All right, let's solve this bad boy for x. Okay, how would I move a positive 6 to the other side? I would subtract 6 on both sides, which 6 minus 6 cancels and turns to 0. 90 minus 6 is 84 degrees. And like normal, I'm running out of room. Guys, I'm going to squeeze it in over here. All right, so we have 4x equals 84 degrees. Okay, this one up here. Sorry, guys, running out of space. Okay, I'm almost done, though. The 4 is secretly multiplying to the x, so how would I move 4 to the other side? Yes, I would divide by 4 on both sides. Okay, which 4 divided by 4 cancels and turns to 1. Okay, 4 and 84, I'm going to chunk it up to help me do this mentally. So 8 divided by 4 is 2, and 4 divided by 4 is 1. Okay, so x equals 21 degrees. Oh, man. Okay, which technically, you guys, we are done because this problem actually asked us to solve for x. Remember, in geometry, a lot of times, we aren't done when we solve for x. But this time, we are. But it's always good to check our answer because sometimes the demon cats get us and we make math errors. So we need to check our work to make sure x makes sense. So I'm going to make sure that 4x plus 6 will give me 9 degrees. Because if it doesn't, I need to reevaluate my answer, possibly my life too. But, you know, we'll see about that. Okay, so I'm going to say 4x plus 6 better equal 90. All right, let's see. So 4 times x, which now that I know x is 21, what can I do with that to help me check? What can I do with this answer into 4x plus 6? I do substitute it. Don't even try to drop a p-bomb. Watch yourself. All right, 4 times 21 plus 6. All right, let's see if it equals 90. Okay, 4 times 21. Okay, 4 times 2 is 8, and 4 times 1 is 4. Okay, so 84 plus 6. Let's see if it's 90. 84 plus 6. Holy hot dog. It is 90 degrees. And 90 equals 90 every day of the week. So bam, our answer is right. And we're excited because we checked it and got a true statement. Wow. Guys, so on the next problem, we're going to be incorporating the other property of inscribed angles that we talked about, where more than one inscribed angle intercept the same arc. It's going to be nifty. All right, guys, go ahead and get started on example 4. Thanks for having a fun time with me like we always do.